All right, so some right triangle application. Here's two words. Well, yeah, they're two angles that show up in almost every right triangle application problem. The angle of elevation, and I'll just show you the other one because it kind of flashed up there, the angle of depression. I would encourage you to take a moment to jot down something about those two definitions, angle of elevation, angle of depression. Okay, as you're going to find out, it's what you measured yesterday. Okay, they're really popular for right triangle applications. In fact, it's almost always what ends up being measured or given. I want to label it on yesterday's sketch if you actually want to kind of quickly recreate a simple right triangle situation like even yesterday's. I want to make sure you understand where these two angles are. Okay, the angle of elevation, as it says up there, is always made with the horizontal and a higher object. Another way to think about it is that's when you're standing on the ground. That's when you're down below. So the angle of elevation again, that's actually what you measured yesterday. Okay, now maybe you're saying sounds pretty straightforward. It should, but I'm going to tell you it's the angle of depression that that sometimes gets kids. Okay, so there's something you got to be careful about with the angle of depression. And to maybe help you a little bit, it is not this angle. Not that angle. Go ahead.
Is it like the same angle, but like if you flipped it upside down?
The same angle if you flip it upside down, like the horizontal's at the top. Anything to add to it, Hannah?
No.
Okay, very good. You're exactly right. In fact, when you said it's the same angle, that actually is also 100% true. Take a look at this sketch. Think about some basic geometry. We have two parallel lines cut by a transversal. Kind of like Owen said, we have a triangle that flipped up here. All those things are completely true, that they are actually the same. Again, they are equal. And I hope you get the idea that it's with the horizontal, because again, that no right there, that's kind of the part that gets kids. I hope that you don't do that, but that's not made with the horizontal. That was made with the vertical. Okay, so we have an angle of elevation, angle of depression. Okay, now those two words kind of just allow us to be a little more technical about some application. And I'll tell you what, why don't you see if you can basically apply them to number 26. As you look at number 26 on 327, it's kind of like just a good old tried and true right triangle application problem. It's a nice, pretty standard. And so maybe you can just even set it up. You can solve it. Just kind of want to give you a chance to see if you can get all this put into one problem. Okay, as you're probably noticing, there's a sketch that would be required. I try to draw it. Where are the different parts of this scenario? You've got a lighthouse, you got a boat. You never will need to put information into the problem that's not given. So if they don't talk about somebody's eye level, kind of like the little catch from the lab, you don't need to worry about it. They do actually tell you to draw the triangle down to sort of the bottom of the boat. In other words, the water line. You never need to assume something or put in some numbers that they don't give you. How you doing? Just as far as the answer goes, just in case you're there already, it's kind of really small. It's like 1. It's like 1.0, 1.09. Okay, now if you're not getting that, maybe there's something that we can help you to straighten out real quick.
I had a question.
Yeah, it would. Yeah, it's kind of like right at sea level. Sea level. All right, did you remember how many feet are in a mile? Kind of like a little extra piece to this. Good little number to remember, 5,280. Okay, so again, we have the little extra piece here where you have to get everything in the same unit. So 13,000 feet compared to 250 feet. Listen, again, there's different ways to go about this, but I still want to go over it just to make sure that we're clear that we're technically finding this angle up here. This is the angle of elevation. Excuse me, angle of depression. So we are technically finding that angle. But did you make the connection? Because it makes the problem a lot easier that you also can be finding this angle. Okay, the truth is that for me personally, I prefer that angle because it's in the triangle. Otherwise, you kind of have to like make an extra triangle. And you don't have to do that. You can just stick with the main triangle down here. So for me, I'm going to call this theta. Maybe you called it A, B, or C or something, or maybe you didn't call it anything, but that is going to tell us to use tangent, essentially, of our two sides. So it's the tangent of theta equaling those two sides. Actually, I guess you end up using inverse tangent, and that's how you get 1.09. I kind of forget how far you can see at the beach, like how far to the horizon. Is it 5 miles or so? Anybody know? Okay. I forget when you see those ships way out there, but it's not real far. And even though I'm only up 250 feet, it's still going to be a really small angle for that distance.
It's 3 miles.
3 miles, so it's not even 5. So the ship would be just like a little speck on the horizon. Just thinking about the beach there for a second. Okay. One more application, and it's just kind of like a good. Yeah. Assume those kind of things. Assume that you can get right angles for these right triangle applications. One other application, okay? And the truth is, when I give you the assignment, it's going to require you to put spins on any kind of application. But this one I'm going over because it's kind of like a specific one that I wouldn't expect you to suddenly know the answer to. But it has to do with right triangles. Ever notice one of these signs? Okay, I always like looking out the window. When I was a kid, I didn't really have other stuff to look at, phones and stuff. I actually would just look at the map. One time I followed Route 30, little random information. Route 30 actually goes from Atlantic City all the way to Oregon. It goes the whole way to Oregon. Of course, there's other highways that have kind of been built, but I kept turning the page, following Route 30. But anyway, you go up north a little bit, maybe even go over to the Galleria Mall. Is that mall still there? But you get some highway signs, okay, basically describing steep roads for trucks. So what does this mean? Let's talk about it a little bit. I don't expect you necessarily to know. It is a percent, though. Interesting, a percent. I wonder what a percent has to do with like a steep road. That would be a steep road, even would be very bumpy. Well, when you think of a percent, it's always out of 100. So now we kind of have two numbers that would fit into a right triangle. Okay, now what's just happened here is I put a right triangle kind of under the road, just so you get your bearings straight here. But I'm trying to help you to see how maybe we could have two sides that might fit with two numbers. Again, 6% is actually two numbers. It's 6 and 100. And so it turns out that it's always going to end up being the rise and the run. It's going to end up being the rise and the run of the triangle, of course, that is describing the sort of sloped road. I actually have that down as something that sometimes people want to say. Okay, but 6%, 6 over 100, is really just the rise over the run. Doesn't matter what it's measured in, because it's just a ratio. So it could be 6 feet over 100 feet, 6 meters, 100 meters. You get the idea. It's a percent anyway. Okay, now you say, so what do I do with the problem? This would be a common question. Angle of elevation. Angle of elevation. Remember, I told you angle of elevation pretty much shows up in just about any right triangle application problem. Just some things to realize. The angle of elevation would kind of be like under the road. It's just going to come out to be 6, like maybe even 6 degrees. Okay, I doubt it, or else they would have just said that it's a 6-degree road. Kind of interesting when you discover what it does come out to be. As you think about, once again, tangent. Looks like tangent's pretty popular today. Opposite over adjacent. Actually, look, it's actually going to end up coming back to 6% anyway. In fact, you just end up doing the inverse of 6%. Check it out. It's kind of neat just to find the answer, but the inverse of 6% is not 6. It's actually 3. 3.43. My drawing is not to scale, but a 3-degree angle would be dangerous when you talk about mass and velocity of a large truck. That's why they have those runaway truck ramps. Have you ever seen the runaway truck ramp? Big pile of stones that if the truck loses its brakes, that he literally has to ram into this big pile of stones. There's like 3 big piles. And hopefully by the time you get to the last one, the truck has stopped. Okay, highway grades. Percents, but they relate to angles. All right, let me give you the application. You're welcome. So again, this is really your first assignment. Okay, but an assignment is really just, it's graded for correctness. So it's a little more than just the nightly homework.